Okay, as we can see, the board's firing up. Our learning target is to calculate the actual yield of a reaction given the reactants. As you're going to see, this is a little bit misleading because we're going to calculate from products to reactants, reactants to products, vice versa. So it's not just given the reactants. I could give you a product and say, okay, how much of the reactant do we need? So you will see that coming up here. But we are going to use our stoichiometry to convert from products to reactants and vice versa. Now, our success criteria, we got a bunch of them, but I'm just putting them all together. Okay? We need the molar ratio from the balanced equation. We're going to take that molar ratio and convert from one substance to another substance. We're going to calculate the moles of products if we are given the moles of reactants. We've done all that already. Okay? That is nothing new. The new part are these last two bullets. To calculate the volume of products of a reaction if we are given the mass of the reactants. And the second one is to calculate the volume of products of a reaction given the volume of reactants. Now, one thing, it's important. We dealt with the molar volume when we talked about molar conversions. Now, when we have molar volume, we need to have what? State for the substances. We need STP, and it's got to be what? A gas, right? We need a gas, we need STP, then we know that we have 22.4 liters. So when we're dealing with this volume, this mass to volume, this volume to volume, it's going to be dealing with gases. Here's our very first example. Go ahead and copy this down in your notes, and then I will work it on the board once you get it copied. The question states, what volume of chlorine can be produced by the electrolysis of 500 grams of aluminum chloride at STP? Now, once again, I love these types of questions because it's relying on you to be able to do a lot of things that we've already studied here in chemistry. Number one is you have to be able to predict the reactions to come up with this equation because everything is not given. Now, this is a fairly simple one because we're going to take aluminum chloride, and it says it's undergoing the electrolysis. So we put that electric current in there, and it is going to decompose to its elements, the constituent elements. Aluminum and chlorine, we know chlorine is a super 7, so it's got to be diatomic. So I have my skeleton equation. I need to go back through and balance. So not only did I predict the reaction, now I got to balance it. I can see even odd problems with my chlorine. So I got to get both of those at even. So I take them both to 6. And by doing that, I need to have 2 aluminums. So now I have a balanced chemical equation. So I have to do that before I can even get into the math part of my equation. I am given 500 grams of aluminum chloride. Notice that that is one significant figure. Okay? Those zeros are placeholders, so I only have one sig fig here. Mental note of that. So I'm given a mass, and I want to find the volume of chlorine. So I'm going to have to go mass of aluminum chloride to volume of chlorine. So I'm going to start out with the 500 grams of aluminum chloride. I'm going to draw my conversion boxes. I'm going to draw a big, long conversion box because I'm going to have multiple steps in here. My very first step is I have to go from grams to moles. So I've already calculated my molar mass. It's 133.3315 grams of AlCl3 is equal to 1 mole of AlCl3. My grams cancel. I've now converted that to moles of aluminum chloride. This is the step now where I use my molar ratio, okay, from my balanced equation. 2 moles of aluminum chloride will produce 3 moles of chlorine gas. My moles cancel, so now I've converted this into moles of chlorine. Well, I didn't want moles of chlorine, I wanted volume. So I know that 1 mole of chlorine gas has a volume of 22.4 liters of chlorine gas. My mole cancels. So now all I have to do is get my calculator out and do my math. 500, excuse me, divided by 133.3315, multiply by 3, and divided by 2. Multiply it by 22.4, and I come up with a value of, my label is going to be liters of chlorine. Now, my value comes up to be 126. But how many sig figs did I tell you I had? Tyler? I only have 1. How many is 126? That's 3. So what I have to do is I have to put in some placeholders right there because I can only have 1 significant figure. So my correct answer is 100 liters of chlorine. Any questions for me on that particular problem? All right, good. Go ahead and copy this one. Here is our second example today. What volume of oxygen is needed to burn completely 35.0 grams of ethyl alcohol at STP? So, ladies and gentlemen, what type of a reaction am I dealing with here? Carly? A combustion reaction. Good. So I'm going to take my ethyl alcohol, C2H5OH. It's going to react with oxygen gas. And my products are going to be carbon dioxide and water, because that's my products of a combustion reaction. So where do I start when I balance this? Anybody remember where I like to start balancing this? With carbon. So I'm going to put a 2 right there, so my carbons are balanced on each side, 2 and 2. I can see my hydrogens, 5 and 1 is 6. So I've got to put a 3 there to give me 6 hydrogens. So now on my product side, I see 2, 4. 4 and 3 is 7 oxygens. So if I put a 3 here to give me 6, plus this 1 right here, that gives me 7 oxygens. So I'm saying right now that is a balanced chemical equation. Would you agree? Would you agree with me? All right, good. Now I've balanced my equation. Okay, I'm given 35 grams of ethyl alcohol. I want to find what volume of oxygen. So I'm dealing with both of these on the product side, but it doesn't matter. Or excuse me, the reactant side, but that does not matter. I'm okay with that. So I'm going to take 35.0 grams of C2H5OH. I'm going to draw in my long conversion box. And I need to go from volume, or excuse me, mass of ethyl alcohol to volume of oxygen. So I need to get the molar mass and convert this to moles. 46.0688 grams of ethyl alcohol is 1 mole of ethyl alcohol. So I've converted that from grams to mole. Now I'm going to use my molar ratio. I know that 1 mole of ethyl alcohol needs to have 3 moles of oxygen in order to react. So my moles will cancel. So now my final step is converting that into oxygen, a volume of oxygen. So I know that 22.4 liters of oxygen is equal to 1 mole of oxygen at STP. So my moles will cancel. I have my final answer labeled liters of oxygen. When I go through and do the math, 35.0 divided by 46.0688 multiplied by 3 multiplied by 22.4, that gives me a value with 3 significant figures, 51.1 liters of oxygen. Questions? Go ahead and copy this third example down. Sulfur dioxide combines with oxygen to form sulfur trioxide. To produce 50 liters of sulfur trioxide at STP, how many liters of sulfur dioxide will be required? Okay, I'm looking at this and I say, okay, here is my skeleton equation. I need to balance that equation. Well, on my reactant side, I have even numbers. On my products, I have odd. So I am going to put a 2 here. So that tells me that I have 6 oxygens now and 2 sulfurs. So I have to put a 2 in front of that sulfur. By doing that, that gives me 6 oxygens on both sides, and it gives me 2 sulfurs on both sides. So I have now balanced this equation. Now, I have 50 liters of sulfur trioxide. By having that decimal point right here, that decimal point tells me that that 0 is significant. So I have 2 sig figs there. So I'm starting out with 50 liters of SO3. And I put that decimal just to remind myself that I have 2 sig figs there. So I am going to go from liters of sulfur trioxide to liters of sulfur dioxide. Put in my long conversion boxes. And I know that my first conversion, I need to go to moles. So I know that 22.4 liters of SO3 is 1 mole of SO3. My liters cancel. I look and I say, okay, my molar ratio, SO3 is 2. 2 mole of SO3. I'm trying to find SO2, which is also 2. 2 mole of SO2. So my moles of SO3 will cancel. My final step is I'm going to liters of SO2. Well, I know that if I have 1 mole of SO2, that is 22.4 liters of SO2. Whoa, 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 that's a 3. SO2. My moles of SO2 cancel. So I am going to get my final answer in liters of SO2. Now, what do you notice here, folks? What do you notice? Well, I've got a 22.4 on the bottom and one at the top. I've got a 2 at the top and 2 at the bottom. If I do all this math, what's it going to equal? 50, right? So I don't even need to do that math. I know that my answer is going to be 50 liters because I'll multiply by 2, divide by 2. Now, do you think they all work out like that? No, they don't. Okay, this just happens to be one that worked out as so. Now, what I want you to do, folks, this last one, you need to work and then bring it up to me to get it checked. So, go ahead and work this last problem. Bring it up to me. I will check it. Once you're done with that, you can start on your WebAssign.